First in line today are Cogitare, who will present TrainServ, software which harnesses data and the latest tech to help ops and planning improve. In terms of passenger experience, this is all about learning from historic performance and events to get the best timetables and minimize delays to passengers in the future. Continuous improvement. Simon Greenwood, performance analysis manager at GWR, will start by explaining what GWR are planning to use the software for. Simon has worked as a system engineer and performance specialist across the industry, Network Rail, Steer, and now GWR. Simon has been trialing the software and feeding into suggested improvements over the duration of the project. Larry Faulkner, train system expert and director at Cogitare, will then show you TrainServ in a bit more detail. Larry has the diverse experience of working in the industry as a rail economist, planner, and systems engineer. Larry helped TfL put into place software and processes to optimize the railway, and a lot of this knowledge and culture of every second counts has fed into TrainServ. Now, over to Simon.
Thank you. Good afternoon, everyone. My name is Simon Greenwood, and I'm the Performance Analysis Manager of Great Western Railway. I'm always very interested in new tools that can help us generate meaningful insights more quickly and accurately, and particularly tools that help us better understand the performance of timetables, either current or prospective. That's why we've joined forces with industry partners to pilot and develop various innovative tools, such as the Risk Solutions Performance Model funded by RSSB, but also TrainServ, the tool we're focusing on today. Whereas the risk sol modeling is all about modeling future timetables, TrainServ is all about shining a bright light on the current timetable and quickly highlighting where the problems are. Can I just check, can you hear me okay?
Yes, we
Good.
can.
I will carry on. For existing timetables, we're interested in gaining a detailed understanding of actual train movements, what may have impacted them, key interactions, and patterns at junctions, and other locations where time is routinely lost. This is about gleaning as much insight as possible from the train timings data, which could be truss, TD, or GPS, to ensure that any performance issues are rooted out and hopefully resolved in the next timetable change. Realistically, truss data is not accurate enough as the seconds are truncated. Therefore, we have to use a combination of GPS and TD data, and these are the data sources that TrainServ uses. For the GWR pilot, we're just using TD data for now. The way we would traditionally handle GPS or TD data would be to download the data from somewhere like Aegis or ITED, and then process it manually, either in Excel or tools like R, to produce the required analysis. If we know what we're looking for, tools such as Quartz enable you to study specific stations or trains, but of course we don't always know what we're looking for. Although we've developed some quite good spreadsheets for working with timings data, it can be very time consuming to calculate, for example, average dwell times or average run times manually. And timings data does stray into big data territory when we're looking at a few months worth of train timings. So our train planning team, amongst others, are very excited by the potential of TrainServ to help optimize dwell times and run times. And they continue to experiment with the tool, aided by myself and the performance team, to explore the various ways we can use the tool to generate insight and understanding of timetables, and hence improve performance. And with that, I'll hand over to Larry to go through the tool. Larry.
Oh, thank you, Simon. I'll just share my screen. Can everyone see that? Okay.
Yes, we can.
Great. So now it's for me to tell you a bit more about TrainServ and also our first of a kind sort of user trial. So the trial was to work with knowledgeable users like Simon from planning and performance teams to feed into sort of improvements in the user interface and reports. Effectively, you know, we want to make sure that this software does what the users want it to do. Yeah. Now, our partner organisations and users involved are listed at the bottom of this slide, from MTR Elizabeth Line through to HS2. Now, you might ask why so many, since most first-of-a-kind projects just have one partner or two. Well, quite simply, everyone who we asked if they were interested in partnering before said yes, so that's why. We would also like to take this opportunity to thank the sort of DFT and Innovate UK for funding the trial, but also to the RSSB, who've also funded some of the development of passenger-related functionality, and driver reports. Yeah, we have also done although I must say the bulk of development has been funded internally, because there's about 50 person years that have gone into this so far, into this software so far. Okay, so first of all, a very quick introduction to Cogitare. We are a software house that's specialized in rail, and effectively a team of software developers, functional experts, and data scientists. So what is TrainServ? Well, it's an app which converts data into easy to use information to help ops and planning do more for less. Okay, by the more, we mean improved performance, timetables, and safety for passengers and freight, with the knock-on impacts for customer satisfaction and revenue, and building back the railway better. And in terms of the less, it's saving staff time and traction energy. It's all about getting the best possible railway for our passengers and freight customers. So the TrainServ app is cloud-based, and as a minimum, we have 3 inputs. We have a basic sort of infrastructure model, a sort of berth network. We have signaling data, which here is the train describer feed, which shows trains' movements in signaling blocks. And we have the timetable. And this is the data that we've used, for example, for GWR. And that gives a wealth of information for planning and performance teams to help understand and improve both. Then we have optional inputs, because we can add GPS or even better OTMR data, the on-train black box, and that gives us more accurate timings, particularly for station starts and stops. And it also starts giving us valuable information for driving teams. Then another optional input is passengers, where if we add passenger data, then we can start exploring train delays in terms of passenger impacts, and also provide sort of crowding reports. And this is useful for the station and control teams. So in short, it's all about us empowering drivers, planning and performance teams, station and control teams, empowering these people to do their job better by making the data accessible and easy to use. Rather than an AI sort of approach, give it all to the computer to do, we're saying that there are a lot of good minds working on our railway. Let's combine person and machine to get the best outcome. Okay, so let's actually take a look at how TrainServ helps do this. So here I'm going to do what you're never supposed to do, which is a live demo. So okay, so here we're looking at sort of Great Western Railway. So I've just selected Readington to Paddington. I want to have a look how the most recent, sort of after the most recent timetable changes, how it's performing. So I've chosen from the 3rd of March when it started this year, and I'm looking at 7 to 10 a.m. And I've decided just to look at Great Western Railway results for the time being. Okay, so sorry, there's the first. Yeah, so if I'm looking at run times, then one of the first things I can do is I can actually automatically look at all the worst run times compared to timetable from the timetable since it's been performing. So here, for example, I've got the links ranked from worst to best. And if I just pull out one where the runtime looks about right, for example, like Paddington to Royal Oak Junction, then the first thing I get is the distribution of runtimes. So effectively at the bottom, this is telling me the band, 55 to 60 seconds or 60 to 65. And then I'm having a look at the proportion of trains in that band. So the grey is telling me that this is the timetable runtime, and the yellow is telling me this is the 25th percentile, which we typically sort of set the SRTs to, and the green is the 50th percentile. And I can adjust these percentiles to see wherever they sort of fall on the graph, for example. Yeah. And then if I want I might say, well, okay, these are the run times I'm seeing, but how does this differ between different trains? So for that, I can go to the box plot where I have now got the variation we see for each individual head code in the period provided. And it should say here, the red dot is the timetable. So this is saying it's 1 minute. And we're seeing that most trains are probably in the 1 to 1:15, but there are some trains which are regularly 1.5 minutes, yeah, or more. I can then also dig into one level detail, zoom into the data more and go to a sort of scatter plot. And here I actually see each of the individual trains. So I can, for example, see, oh, there was a problem with the 5L22, and the worst runtime we had was on the 11th of March. Yeah, so this is a way that we can sort of zoom in and find out where the issues are. And now I will hand back briefly to Simon to explain how do you use this sort of runtime functionality. And it should say we're introducing all this for dwell times as well, including the ranking.
Yeah, thanks, Larry. If you can't hear me, just say. But during this pilot, we've used TrainServ to quickly tell us what the average dwell and runtimes are for a section of our choosing, without the need for any manual calculations. More importantly, as we've seen, TrainServ automatically generates this ranked list of poor performing sections or stations listed from worst to best for the area and time frame of our choosing. This could be the average over many months, covering millions of data points. Or it could just be yesterday, compared against previous performance. And this can demonstrate things like temporary speed restriction locations and their impact per train. So TSRs, for example, would normally be quite cumbersome to identify and quantify. Gojitari designed this automatic ranking functionality very much in conjunction with GWR, as we wanted a tool that was able to present not just the data, but some degree of insight as well. We've also used TrainServ to quickly debunk various myths relating to performance and runtimes. For example, as the TD data includes all train operators that run over the selected geography, we've been able to compare GWR performance against other operators that run over the same routes and come to our own conclusions pretty quickly. This sort of high-level analysis simply wouldn't be possible without tools such as TrainServ, partly because most of our data sources only contain GWR data. For example, Acumen, Bugle, and Aegis are limited to GWR data only. ITED, for example, does contain all data for all TOCs, but again, we would be required to download the data in large quantities and then process it by hand. And this isn't something we can realistically do on a grand scale. This analysis has already proved useful for internal train planning purposes, but also as part of cross-industry timetable discussions. Back to Larry.
Oh, thank you, Simon. So the next report that I will show you is the train graph. So again, here we've got, we're looking at performance of the new timetable over the last sort of 2 weeks between Reading Station and Paddington, between 8:30 and 9. So how do you read this? Well, you've got the stations on the bottom. It may be a bit small, and then the dotted line is the timetable time, and the solid line is the actual times of trains. So effectively, if the solid line is below the dotted line, then that means the train's running early, and if it's above it, it means it's running late. Now, planners and performance teams are telling us they like this report because they quickly see where their problem trains and locations are. Like, for example, here we can see that at the 50th percentile, sorry, I should explain that this is, here it's 2 weeks of data. It could be 6 months of data if we wanted. And we can look at the 50th percentile or any percentile of actual compared to timetable. So by the 50th, we mean the 5th out of 10 trains in terms of lateness. So here we can see that most trains are running on time or early. But if I change this to, let's say, 80 and refresh it, then I can see that there are some delays sort of creeping in. Yeah, for example, sort of this train here, the Cheltenham to Paddington. Yeah. So this also tells us at what point the service starts falling down. And then I can also, filter it by operator and do many things like that if I want to. For example, let's just try filtering it for Great Western Railway. Yeah, and now we've got rid of the TfL rail trains or Crossrail trains, and we're focusing on GWR. So it's interesting here, for example, because we start also seeing the interaction between trains, because we can see that when we look at the 80th percentile, then this train, which is the Worcester to Paddington, yeah, actually often runs late. Well, it runs early and then it starts waiting outside Paddington and then causes knock-on delays to the train behind it. Yeah. So, okay, so over to you, Simon, about how you at GWR are using this report.
Well, you've just shown a very clear example, but basically having a train graph view that can show both real-time and historical average performance it's proving very useful. So the historical graph view is great for finding trains or junctions that are subject to recurring performance problems like the one Larry just showed. Another example, Heathrow Airport Junction, is where the airport line diverges from the Great Western Main Line. And here we were able to quickly see some specific interactions between our high-speed trains and Heathrow Express services. The train graph provides a very clear visual of the interaction, and we can choose to see the average train graph over the selected time frame or other percentiles as Larry just showed. So this is also functionality that was developed in conjunction with GWR. Now, especially at a time when we're running reduced timetables, ourselves and probably all operators are being encouraged to root out these sorts of issues whilst train numbers are down and resolve them through amendments to the timetable. And although other available tools do enable some degree of train graph functionality, we found TrainServ to be fast, powerful, flexible, and able to handle big data to provide that deeper insight. And the live train graph view is useful when launching new timetables or timetable tweaks to check the results in real time without having to wait for the data as we normally would. Back to Larry.
Okay, thank you, Simon. So now I'll actually switch to the C2C network where we have all the data feeds to show you some of the additional reports we can also produce when we have things such as GPS or OTMR data or passenger data. So I'll flip through these quite quickly just to sort of give you a feeling, but we can produce multiple speed distance graphs which show you the performance of trains in terms of their speed relative to the speed limit, which is in black here. And also we can filter by head code, and this helps understand, people find it helps them understand when there's a lot of runtime variability, what's causing that runtime variability. We also have we can then also see the details of any particular train and which date it was operated on. Yeah, okay. Then we also have a sort of a playback sort of functionality where you'll have probably seen this before. You can actually sort of see trains running around the network, and this is useful to sort of understand how junctions are sort of performing. Yeah. And then another report which we can then produce with passengers is quite an interesting one. Not that the National Railway is particularly interested in this at the moment because it's not a contractual measure, but what it is, it's measuring performance in terms of the passenger impacts. It's putting the passenger first, since people will follow the metrics that they're encouraged to. So what we're saying is that the average journey time here I've chosen between Fenchurch Street and Shrewsbury Ness is about 73 minutes, and of that is about 66 minutes on train time and about 5 minutes wait time. But on the day selected with actual train delays, that average passenger journey time increased by 2 minutes, with on-train time going up by 1 minute and platform wait time going up by a minute too. So this is a sort of TfL approach to, if you really do want to put the passenger first, then you have to measure performance in terms of passenger impacts to focus, on the trains and delays that impact on the most passengers. And it does it intelligently because it's got routing algorithms. It doesn't just look at a train being late multiplied by the typical number of people on that train, it actually looks at the alternative trains people can take. So I think watch this space, because the National Railway is likely to be moving in this direction in terms of performance measurement in future. Then there's also a lot of information we can do to sort of support driving and look at individual trains. So here I've chosen the 1534 from Fenchurch Street to Shrewsbury Ness. This was actually on the 12th of August last year. I'll show you why I chose it in a second, but the orange is the train we've selected. Again, the gap, we can see it's pretty much dead on time since the grey and orange line are touching, except right at the end. And this graph is actually down to berth level, and it shows us all the train movements before and afterwards. But then I could also, for the selected train, I can investigate in detail the sort of speed distance curves for each curve to see how, and these are the types of reports that are helpful for sort of drivers. And for example, when we were looking at the train being impeded, I can, for example, show events such as the AWS, which gives us an indication of trains at caution, and sure enough, the train is impeded on all of its approach to Shrewsbury Ness, as we can see here. We can also get a detailed breakdown of dwell times, by station. This is thanks to the OTDR data, where we can actually break it down into all the different elements, such as traction to wheel start, interlock release to door close. And for example, the grey is actually the time that's available for boarding and alighting. But you could also check things that the driver is actually spending long enough on the interlock to traction, because that's actually the time the driver has got to do the PTI checks and make sure that no one is stuck in the doors or no pets, as sadly happened recently on GTR. Now, there's also plenty of functionality to sort of automate driver competence assessment. So this is all about seeing how the drivers followed the driver policy, and seeing where they're not, when they're not applying the rules. So we've got a system of notifications in terms of green, sort of orange and red, and I've chosen this train because it's one of the few ones where we do get red notifications. You'll be glad to hear they're very rare. But for example, I can see one here, red for speed, and then if I click on it, I can get taken straight to the context. So okay, I can see that the driver exceeded as he or she left Limehouse. Okay, they saw the 50 mile an hour at the end of the platform and immediately accelerated. What they forgot is that there was a 20 mile an hour before the platform, which is shown by the black line here, which is corrected for train length. And actually they had to wait until the back of the train had cleared that speed restriction before re-accelerating. Then we have an analysis of braking, AWS signaling, and cab mobilization, time and traction reports, but I won't go into that in sort of in any detail, since that would be for another time. Okay, and with that, I'll come back to just the tail end of my sort of our presentation. Okay, so in short, why TrainServ? It's all about empowering the performance planning and driving teams and station and control, about making data accessible, giving them data in a format that's easy to use so that they can do their jobs better. And if you are interested, that could be, for example, might your organization be able to use TrainServ? Because by democratizing the data and making it accessible, it means there are many, many more uses and potential users for the data. Even senior management, for example, can use it. Another area of potential interest is we've got a big integrated data set within TrainServ, which contains all the OTDR, signaling, infrastructure data all joined up. Might it be interesting to unleash some AI on it, for example. I know the University of Huddersfield are doing some statistical analysis on this integrated data set at the moment. Or a third potential area is partnering, because we are currently working with a couple of other sort of partners to develop joined up data and software solutions. It's all about how can we work together to offer our customers a house to buy rather than offering them bricks and saying up to you to build your own house. Anyway, or if you just want to find out more about what we're doing and why, then I'd love you to get in contact, and here are my contact details. So with that, I will stop talking and hand back to Vanita, and thank you very much for listening.
Thank you, Larry and Simon. In another hat, I've been working for policy making, not particularly for running trains, different data sets and trying to put them together. And I think putting data sets together is a really fascinating way forward. I think there's a lot of untapped potential there.